All right, we're going to talk about exponential functions and look at their graphs today. So the first thing we need to do is remember the exponential parent function. Remember, the parent function is the most basic form of a function of the same type, same shape, and what it looks like on the graph. So the parent exponential function is f of x equals b to the x power. And b is your base, and x is your exponent. And remember, when we're dealing with an exponential function, x will be in the exponent position. If b is greater than 1, the function is an exponential growth, and it is increasing. So when we look at the function, if it's exponential growth, the graph is going to go up. It's going to be increasing. If b is less than 1, the function is exponential decay, and it is decreasing. So if it's exponential decay, the graph will be going down. An asymptote, this is a new word for you to know definition of, is a line which the graph gets close to but never crosses. So your graph will approach this line, but it will not cross it. Take a minute, make sure you have these notes, and then move on. At any point in time, if you need to pause the video, go ahead and do so. All right, we're going to look at the first one and see what it says. It says classifies exponential growth or decay, graph, and then identify key characteristics. All right, so since this is greater than 1, that's our b. Remember, that's our base. If our base is greater than 1, it means it's exponential growth. So number 1 is a growth function, which means it's going to go up when we graph it. All right, so I'm going to make a table of values. You can see I already put some x's here, and you can choose your x's. X's are the numbers across your horizontal axis here. And since x is your independent variable, you can choose the numbers you plug in. I'm going to choose numbers close to the origin. That just makes it easy to graph. And it makes it easy to plug in. So you do want to have negative and positive numbers. So that's why I chose these. So if I take negative 2 and plug it in for my x, that means I'm going to have 2 to the negative 2 power. And if you remember your properties of exponents, a negative exponent means it moves to the bottom. So 1 over 2 squared is 1/4, because 2 squared is 4. All right, take negative 1. So I've got 2 to the negative 1 power. Again, it's a negative exponent. So properties of exponent says it moves to the bottom. So 1 over 2 to the first is just 1/2. 0, properties of exponents, anything to the 0 power is 1. 2 to the first power is 2, and 2 to the second power is 4. Now I can take these ordered pairs and plug them in. So the first thing I have is negative 2 and 1/4. So if I come over negative 2 on my x and I go up to 1/4, it's going to be, it's hard to write on here. Let's see. And then 0, 1, 1, 2, and 2, 4. And you can see exponential functions, once they start growing, they grow very quickly. So you're going to sketch the graph. Okay, it's approaching this line, but it's not crossing it. And then if you sketch the graph, it's going to look something like this. All right, then we need to determine key features of the graph. So our key features, we've looked at these before. Our domain is our x's, so it's going to the left and to the right. Even though it's going up more than it's going to the right, it's still going both to the left and the right forever. So this is going to be all reals. And our range, it's approaching this line here, but I don't think it's going to cross. Like this fraction is going to get smaller and smaller and smaller and smaller fractions, but it's not going to get to 0. So our range is going to be y greater than 0. And then the end behavior tells what the graph is doing at each end of the graph. So as x approaches infinity, positive infinity is going this way. So as x goes positive, what does f of x, or what does my y do? Y is the same as f of x. It is also going up. So that is also positive infinity. All right, what happens as x goes to the left or towards the negative infinity? Okay, it looks like it's approaching this line here. So f of x is approaching 0. All right, my y-intercept. My y-intercept, if you look here, is going to be on my table, 0, 1. And the isotope is the line in which the graph approaches. Since the line is approaching 0, this is going to be y equals 0. All right, we're going to skip number 2 because it's exactly like number 1. And we're going to look at number 3. So the first thing we're going to do is determine what type of function it is. F of x equals 1/2 to the x power. 1/2 is less than 1. So that means this one is going to be a decay. Okay, so if it's a decay function, that means our graph is going to be decreasing. First thing I'm going to do is go ahead and make a table of values again. Again, we're just choosing x's. X is your independent variable. It's your x-axis, is your horizontal axis. And I'm just going to choose numbers to plug into my function here. All right, so if I take -2, I'm going to have 1/2 to the -2 power. And again, when I have a negative exponent, that means that it's going to flip this, and it's going to become 2 over 1 squared. So 2 over 1 squared, which is just 4. 2 squared is 4, because 1 times 2 is just 2. All right, then I have -1. I'm going to do 1/2 to the -1 power. Again, it's going to flip it, and that's going to give me 2. All right, the 0, so 1/2 to the 0 power. Anything to the 0 power equals 1. That's by definitions. That's one of your properties that you learned in Math 2. So we have 1/2 to the 1 power is just 1/2, and then 1/2 squared. When you have a fraction squared, you square both the numerator and the denominator. So 1 squared is 1. 2 squared is 4. All right, so again, we are going to use these points to put on our graph. So we've got -2 and 4. -2, 1, 2, 3, 4. We've got -1, 2. 0, 1. 1 and 1/2. And 2 and 1/4. And then we're going to sketch this graph. And you can see decay function is going down. All right, it's still approaching this line, so it's going to be kind of similar to before. Our domain is going in both directions, so it's all reals. Our range is still above this line here, so it's going to be y greater than 0. Our end behavior is going to be as x goes positive, y approaches 0. And this one goes to the left as x goes negative. This one is increasing without bound. All right, our intercept again, my line doesn't quite go through that point, but again, it's at 0, 1 for this one. And our isotope again is going to be at 0. All right, make sure you get these and then move on. All right, we're going to look at one more example like this. So number 5, f of x equals 5 halves to the x power. So this is a fraction, but it's an improper fraction, meaning that the top number is larger than the bottom number. So that means this is actually a growth function instead of a decay. 5 halves is equal to 2 1/2. 2 1/2 is greater than 1. So this is going to be a growth function. So anytime you have something greater than 1, that is a growth function. Right, this means that our function will go up, or it will rise again. All right, so again, I'm going to pick x's and plug it in. This one's going to be a little harder because you've got 5 halves raised to the -2 power. Again, that's going to flip this and you're going to end up having a decimal. So in your calculator, use parentheses and put 5 halves inside your parentheses and then raise it. This has to be an exponent, it has to be a power. So raise it to the -2 power. And when you do that, you're going to see that this equals 0.16. All right, for the next one, you're going to take 5 halves. You're going to raise it to the -1 power. Okay, so that's going to be, it's going to flip the fraction, and that's going to be 2 over 5. 2 over 5 is about 0.4, or it is 0.4. And then 5 halves to the 0 power. Anything to the 0 power is 1. And then 5 halves to the first power, that equals 2.5. And 5 halves squared equals, square the numerator and square the denominator. That is 25 over 4, or we can write that as 25 over 4. 4 goes into 24 6 times, and then 1 left over. So 6 1/4, or 6.25. Since we have the others as decimals, I'll put this one as a decimal as well. All right, now these, again, it's going to keep getting smaller and smaller here. It's going to approach this line. So we got -2, just barely above -2, -1 and 0.4. These are not going to be exact. 0 and 1, 1 and 2 1/2. 2 and 6.25. So 2, 1, 2, 3, 4, 5, 6. We're going to sketch the graph. Again, when it starts flattening out, you know that's where that isotope's going to be. All right. My domain is going left and right forever. My range, again, is still going to be greater than 0. My end behavior, as x goes positive, y is increasing. As x goes negative, y is approaching 0. My x-intercept, again, where it crosses, the y-intercept, where it crosses the y-axis, is at 0, 1. And my isotope is at 0 again. Now, unless we have, we're looking mostly at our parent function here. So unless we have vertical changes, then it's going to be at 0, but that will change at some point. All right.